Now we're going to look at graphing functions when they're in the form ax plus b over cx plus d. Essentially what that form is indicating is that numerator and denominator are linear. All right. So three things you're going to do, three steps. First step, find the vertical asymptote. So you're just taking the denominator, setting it equal to 0, and solving. So 3x minus 4, you end up with x equals 4/3. So the vertical asymptote is at x equals 4/3. I guess we'll leave that there. Horizontal asymptote. There we go. Determine if there is a horizontal asymptote, since the degrees of numerator and denominator are the same. It's the ratio thing, so it'll be 2/3. Right, so y equals 2/3 is a horizontal asymptote. And then you got to just figure out. Maybe I'll see this. Can't click on it because this thing is here. Maybe if I, sorry, hold on. Okay, it's annoying. All right, I guess I can have them all at the same time. Anyway, for the step 3, you basically just find some other points, right? So what that means is choose x values on either side, and then evaluate the function to get ordered pairs, and then you plot the points. All right. So let's look at, there's two parts here to try it. So we'll do one together, and then I'll have you try the other one on your own. 4x minus 3 over x plus 8. This is very similar. So I don't know if I need to write. Denominator here is x plus 8. So if I set that equal to 0, I get x is equal to negative 8. So x equals negative 8 is the vertical asymptote. So we're going to zoom out to make that fit. All right, so the vertical asymptote's right there. Horizontal, again, degrees are the same, so it's the ratio. 4 divided by 1 is 4. So the horizontal asymptote's at 4. We're going to zoom out even more. And the horizontal asymptote is here. So there's the asymptotes. Now it's a matter of finding some points to plot. All right. So we're just going to pick a value for x that would kind of work with this. One that's going to work, and you can really pick any value of x, right? You're really just trying to figure out, like, is it above or below? Because the curve is going to go either way. Either the curves are going to be here and here, or they're going to be here and here. So if I pick an x value, I don't know, let's pick over here at negative 13. All right. You got 4 times negative 13 minus 3 over negative 13 plus 8. 4 times negative 13 is negative 52, minus 3 is negative 55. Divide all that by negative 13 plus 8, so negative 5. You end up with 11. So the ordered pair would be at negative 13, 11. Question might be, how did you pick negative 13? And the answer is, I tried a bunch of these before I hit play, hit record. So you just pick a bunch of x values, and then this one actually worked out pretty nice. So it's at, I'm going to have to zoom out even more. Actually, maybe just go like that. So negative 13 and then up to 11. What if I pick something on this side? The one that worked on this side for me was negative 3. Yeah, negative 3. change the color here. And again, if you end up with a decimal, it's fine. I'm just picking ones that look nice. But anyway, 4 times -3 minus 3, all divided by -3 plus 8. And you end up with -12 minus 3 is -15, all divided by -3 plus 8 is 5. So you end up with -3. So the ordered pair would be at -3, -3. So let's see, I guess each block is 2, so -3 would be here, and -3 would be like here. Yeah, good enough. Anyway, so that's where the graph would be. All right, and again, you're just picking x values, finding a y. When you're using this application, you just need to find one ordered pair on either side of the vertical asymptote, and then the rest of the curve will just kind of flow with that. All right, so let's take a look at the next one. I want you to try this one on your own, and then come back and we'll check it out. First thing I figured out was the asymptotes. One is at x equals 1, the other is at y equals 3. Um, and then I found, okay, then I picked 3 as my first value of x, um, and evaluated that and got 5.5. So I dragged 1 point to 3, 5.5. I did 0 for the, oh, that's not where 0 is. um, anyway, I did 0 for x, um, and you end up with 2 over it, so -2. So it'd be like right here. Um, so anyway, that's where that would be. There we go. Sure. Okay. So that's where the graph would be. That's where the asymptotes would be. And again, if you pick different points for the orange, then that's fine.